If you use artificial intelligence for work, you have probably seen it generate a beautifully written, perfectly structured essay in seconds. But you have also likely seen it do something strange. Mid-sentence, it completely loses the plot and spits out confident, chaotic nonsense. To understand why it makes those mistakes, we have to look at what a large language model actually is. It operates like a version of the autocomplete feature under smartphone keyboard, just scaled up to enormous little. When you type a text message, your phone analyzes the last few words you wrote to guess the most likely next single word. When you ask an AI to write a marketing plan, it is doing the exact same thing. Despite how fluent the output seems, the system does not actually understand the ideas it is talking about. That is simply playing a gigantic game of guessing the next word, over and over again. To see how this guessing game works, we need to look at the setting with the setting effect. This diagram shows how the system reads text. It breaks your prompt down into fragments called tokens. Instead of human ideas, it sees meaningless mathematical trunks, sometimes full words and sometimes just a single prefix or syllable. The system has one strict objective: analyze the pattern of the tokens you provided and calculate what the very next token should be. It does not read for meaning. It solves a mathematical sequencing problem by relying on the billions of data points it absorbed during its training phase. Let's freeze this process right in the middle of a sentence to see how it makes a choice. Imagine we gave the AI the prompt, "The cat sat on the..." This diagram shows the hidden calculation happening behind the scenes. The system assigns a percentage likelihood to thousands of potential options for that single bank space. Those exact percentages come directly from its training data. Because it read millions of sentences on the internet where cats sat on mats, Matt gets a high score, while a word like moon gets a tiny fraction of a percent. There's no crave sound happening. Every English on screen is the result of a literal mathematical calculation. Of those picked the number one highest scoring word, the writing and sound robot repeated. To fit that,
the system uses a
setting called temperature. You can think of it as a dial that controls whether the AI plays it safe or takes a risk. When the system turns this dial up, it occasionally ignores the top choice. It rolls a digital die. Sometimes that random roll lands on a highly unlikely, low percentage word. Suddenly, the cat isn't sitting on the mat, it is sitting on the moon. Once it makes that choice, a process called the loop begins. It glues that choice to the ends you prompt, shifts everything over, and instantly restarts the exact same probability calculation for the next blank space. Entire page stakes is built from this confused loop of guessing and rolling the dice, repeating hundreds of times rapid succession until the system hits and something. Visualize this. Imagine Hanko Clark desperately slamming out sing pieces of iron crack just inches high the speed train. Because it only looks one kiss at a time, the system has no master plan. When it writes the first word of a sentence, it has no idea how that sentence is going to end. And if that temperature dice roll picks a weird, low probability word early on, every prediction that comes after is forced to anchor to that mistake. The system just keeps laying track in the wrong direction until the whole thought derails. That same dice roll is also why you never get the exact same answer twice. If you ask the AI to repeat a task, the random variations in the temperature setting guarantee the tracks will build in a slightly different direction. Every beautiful paragraph the system produces is a shape that emerges in real time from hundreds of independent microscopic guesses. This is why effective prompts matter. To keep that train on the rails, you have to provide clear, specific context. Giving the system strict instructions acts like guardrails, leaving it less room to randomly drift off topic. You can also look into the advanced settings on some platforms. Issue task requires strict facts. Turning the temperature setting down to 0 removes the dice roll, forcing the system to output the most predictable mathematical choice every time. The friendly conversational interface, the system does not comprehend reality or understand human ideas. The simply ideas padres via stringia. His lacks in understanding facts. It will confidently connect patterns that do not actually belong together. In our next video, we will explore exactly how this mechanical blindness leads artificial intelligence to make up completely false information, a flaw known as a hallucination.